Okay, let's continue. So in the last class we have spoken about different types of learning, and we also discussed some examples on each of the types of learning. And then we understood how logistic regression is going to help us in finding out the patterns in the data with the help of dependent variable and independent features. And then we spoke about logistic regression. We used a classification problem where we need the use of sigmoid function, where sigmoid is very much helpful in bring the predicted value to the probabilities. Any predicted value you get it, that predicted value can be mapped on a plot called sigma. On that will be on the y-axis 0 to 1 probability value, and to map on that there will be a sigmoid curve. Those predicted values will be mapped on the sigmoid curve, and that will map indirectly onto the probability value on the y-axis. Right? That's what we have learned from the graph as well as from the explanation. And that is a sigmoid function. That is a mathematical function that is used to map the predicted value to the probabilities. And we have to see now assumptions for logistic regression. Assumptions for logistic regression. I hope all of you have understood what is logistic regression. Dependent variable must be categorical in nature, categorical or any dependent variable that you are going to have. Dependent variable and independent variables. So y equal to x, if I say, so y will be dependent variable, x will be independent variable. I am saying y equal to x. Alright, the equation x is independent variable, y is dependent variable. Now the question is, y is depending on what? X values, because after equal, whatever changes are happening, so once they do the calculation, then only the y value will receive the output. Right? The result. That's why y is dependent on the calculation happening in the RHS. Right? So we are talking about that here. We are saying dependent variable. What is the dependent variable now? Y is dependent variable. Exactly. So dependent variable must be a categorical in nature. The answer that you are trying to find out must be a categorical nature. Independent variable. So x is your independent variable. Should not have multicollinearity, or you can say it must not give multiple characteristics, so that we will be having difficulty in making decisions. Logistic regression, type of basis of categories. Logistic regression can be classified into three types based on the categories. There is one of the regression is binomial regression, binomial logistic regression. In this one, there can only be two possible types of dependent variables. Two possible types of dependent variables. It may be x, y, any value, x or z, any value that you are taking. Types of dependent variables. What are dependent variables? X or y? Right? We are saying two possible types of dependent variables, such as 0 or 1, or pass or fail. That means y is the answer we are expecting, right? So the only answer we will have is 0 or 1, or pass or fail, or span or not span. Will be any one of the two categories. Will be happening. Alright. That will happen in binomial. How about in multinomial? In multinomial logistic regression, there can only be 3 or more possible unordered type of dependent variable. What does it mean? Dependent variable, three possible things are there. For example, we have a dependent variable such as cat, dog, and sheep. Only from 3 categorical things, you have to pick one of them. So that's how you're going to have that.
For a value of x, y can take 3 or more than 3 values.
Yeah, exactly 3 values we say. More than 3 values. Three or more than 3. There can be 3 or more possible and unordered types of dependent variables such as cat, dog, or sheep, or any other number of elements you want to add, you can add them. And in ordinal, it's just a small difference. In ordinal logistic regression, there can only be 3 or more possible ordered type of dependent variables. Okay. Here, you cannot order a cat, dog, and sheep. We can ask you to arrange them. You will not be able to arrange. You don't have any dependency on which you can arrange them, like numbers you don't have. So that's why we are saying here, in multinomial, there can only be 3 or more possible unordered types of dependent variables. That is your answers. Answers can be any 3, but you cannot order them. But in ordinal, what we say, there can be 3 or more possible outcomes you are expecting, but they can be order type, depend on the order type of dependent variables such as low, medium, and high. Now you can order them. If I give these 3 names, you can order them. First, which one will come? It may be the high or low, any one of them. How you are ordering it. Okay. If I start with low, then you have low, medium, and high. You can order them. So now this kind of outcomes where you can have order, we can call them as ordinal. Okay. Where similar thing, but you're not ordering them. You have multinomial. Alright, binomial, you only have 2 options as outcomes. Alright, so these are the types of logistic regression divided based on the different parameters. Got it? One is basically number of outcomes that they are going to monitor. That will be the major parameter we are dividing, and also based on the order of those outcomes. These are the 2 major parameters you just need to remember. Alright. So there can be an interview question on this one that how many types of logistic regressions you understand, you know. So there will be 3 types, and what will be the multinomial? How do you understand and how to explain multinomial logistic regression?
So in binomial, for a value of x, y will take 2 values, either this or that.
Yes.
And for multinomials, for a value of x, y will take 3 or more than 3 values.
Okay.
This or that or that or that can or beyond that.
Okay.
And in ordinals, it takes, it's a multinomial only, but those y values can be ordered, can be arranged in a order.
Okay. But the follow-up question would be, can those that y will take at a time all 3?
So it will take only one of those 3, 3 or more than 3.
Is that right? The question is whether y will take all those 3 options at a time. Like I have low, medium, and high. That y value will take at a time all 3 or at a time 1?
So it ordinal looks like a mix of binomial and a clustering.
Okay.
So binomial it segregates, and through clustering it segregates them.
Means separately
It plots them in different planes.
Okay. In terms of logistic regression, as we are expecting only one value to come out, regression,
Yes.
only one value we wanted. You also understand from the previous examples. So here we are trying to say there can be 3 or more possible ordered type of dependent variables. There will be different types of variables, and we are expecting only one to come out. One will be the outcome out of 3 or out of 4, or how many are there. So we are just trying to say any one of them you can pick, but how many possible values are available to you is the difference. Binomial says I will give you only 2 options. Any one you will choose it. Pass or fail, okay, yes or no, true or false. Only 2 you choose it in binomial. In multinomial they say I will give you more than 2. That is 3 I will give or more. So among them you choose any one of them. You have your more options. That's the change.
So another example you can see, income of a person is here on X years. That is independent variable. And he being low income or medium income or high income is a Y. That's
Right.
it. Low, medium, high is dependent.
Yeah, dependent variables. Dependent variables, and any one of them we can definitely pick it. So in logistic regression, only one value we can get it. That's what assumptions we can make it. Okay, these are the assumptions that we are making. The dependent variable must be categorical in nature. Dependent variable. What is dependent variable? X and Y. Y. Dependent variable. Y. Must be a categorical in nature. This kind of category, like pass and fail are category. Cat, dog, different categories, low, medium, all of them are categorical things. That's assumptions that we have that everybody must agree with. Independent variable, like if you have one value, it must not have multiple values which changes the outcomes. Outcomes variables like pass must not be changed with the fail if it has multiple values at the same time. We should not replace it. Then very important algorithm. If you go to any interviews, you can take a trial interview. You'll definitely find a question on SVM because it is so important as well as so useful tool for any data engineer who will be working in it. Alright, so that is your support vector machine. Okay. Easy to understand and also easy to implement and will implement that. Support vector machine or SVM is one of the most popular supervised learning algorithm. What is supervised learning algorithm? What do we do there? Label data. We supply label data. It means question as well as answer both will send it and will train it. Alright. Most popular supervised learning algorithms, which is used for classification as well as regression problems. What are these classification and regression problems? Anybody? There are two types. Two types, okay. What does it mean classification? What do we do there?
Classify the classification is logical regression.
Okay. So we categorize. We categorize into multiple classes. Okay. So there will be multiple classes. Like if I have two classes, pass and fail. So will you be able to categorize them?
Clustering is also comes under classification.
Clustering will also come in classification. Yes, three classes if I have, so we can put them in different classes. Obviously, independently we can do. Yeah, multi-class classification, we can actually do that. Okay, how about regression problem?
Linear regression.
Linear regression, what do we do there? What happens?
Why is different to X1? Why is it different to X1?
Correct. So why do you use that? Use best fit we wanted to make. So any application that we can think of whenever we hear about linear regression. House price prediction. I wanted to know what is land price or real estate plot price. And how do I do that? How do we do the house pricing? Do we take any other values initially?
Okay. We use regression.
Okay. So initial values are needed or not needed? Yes. Needed. Then only we will have some related values around them. Then we can have more probabilistic values being predicted. Right? Okay. So already we need to have some data being added, and then we'll draw a line, and then we'll try to find out the new value, new questions answer. Alright. Okay. However, primarily it is used for classification problem in machine learning. Very near to that or on the line. This is the best fit point. Alright. So that same thing we are going to apply it here, but a little different style of using that line. We'll be having the three lines. The goal of SVM algorithm is to create the best line, as we also had in regression, or decision boundaries. Understand and remember these keywords that we are seeking. We are saying SVM algorithm is used to create best line or a decision boundary that can segregate n-dimensional space into classes. N-dimensional space where there can be any point that you're putting on a space, and those points will be able to categorize into classes so that we can easily put a new data point in the correct category. Decision boundary is called a hyperplane. Understand? Okay, we'll have a visual graph also. Just understand what we are theoretically what we are trying to do. There will be a graph and there will be some boundaries we will be drawing, and based on those boundaries, any point which is near to those lines will be considered as the best fit point, and based on those points we'll be making the decisions. Like how we are making a probabilistic decisions, here also we'll be making them decisions to categorize. As we already said that they are being used for classification problems. So they basically used for classifying the data points. All right. Before going to the next thing, we wanted to have some imagination. Let's go and bring in some graph. I think we have the graph in the presentation itself. Yes, we have the graph. So we have x2 and we have x1, and we have some line here. You can see there is a line. Okay. So this middle line that we have here, we can call them as maximum margin hyperplane. Maximum margin hyperplane. Okay. You understand what is this margin from the business statistics module? This is your maximum margin. Okay. So further nothing is there. So this is the maximum margin available, and this is your positive hyperplane. This one. Okay. And then we have Then we have the support vectors. That means these are the decision-making vectors which are very near to this dotted line. Okay, so this whole thing that you can see will be the hyperplane, along with these dotted lines, this whole line, and this thing. So whole thing is my hyperplane, which is being drawn as a best fit boundary, which is going to separate these two clusters, two different types of dots. So those points which come very near to these lines, we can call them as support vectors. Based on them itself, we can put the other points which are coming in new points, like new point, new green point. I put it. Where should I put them? The decision I have to make. So that decision will be taken up by or with the help of support vectors. Okay. And we have a negative hyperplane. This is my negative hyperplane. This is my positive hyperplane. Okay. Based on this one, we will be going to make a decision. Okay. This is the decision boundary or hyperplane that we have seen, and this is your parameter that we have. X2 we have and X1 we have. All right. We're not expecting an outcome here. We're just segregating them. We're just classifying them. So that's why we don't have X and Y here. We have X2 and X1. Okay, SVM chooses extreme in 3D space. If I talk about vector, I'll be having X, Y, Z. If I have 2D space, I can call X from Y as my one of the vector. Right? Vector is a point in a space. You can consider it. Okay, extreme points. These extreme cases are called a support vectors, or hence algorithm is said to be a support vector machine. Based on the support vectors, as you are getting those small points, so that will be the boundary after which we are going to draw the boundaries. If the points are very close to the line, you would have made those boundaries very small. If the points are very far away, then you would have made those dotted lines very wider actually. Alright, so those small points which are near to those lines are actually the points. First they will come, then the boundaries will be drawn. Okay, boundaries will not be drawn and then the points will be coming. No. So first the points will come and then we are going to draw the boundaries. Alright, okay. Let's see some more examples on them. Suppose we see a strange cat that also has some features of dogs. You can see both of them look mostly similar. Okay. So if you want a model that can, if you want a model, what does that mean? Model. We discussed about it.
Classification model.
Yeah, classification model. But what is model? Is the question now. I want to understand. I'm not getting what is model. Right? When I read model, what should I understand? Model in terms of car, if I say, I understand. Car model I can understand. Bike model also I can understand. When I'm saying we want a model that can accurately identify whether the cat, whether it is cat or dog. Yes. So when we train our program, it can create its own understanding of data. Okay. That understanding of data will create a structure of how to identify the new features. Okay. Those features are independent variables like x, y, z. All right. So those features list, which I can use in future to identify new things, will be the model. All right. Or in other way, if I want to understand, it is one of the customized algorithm, and that customization happened to the algorithm with the help of data that is supplied. You supplied me the data, that's why I have created a custom algorithm. That custom algorithm now has a capacity and capability to understand whether it is a cat or dog. We have shown them a lot of photos of cat and dog. Now, because of those photos data that has been added, the algorithm has become customized to understand whether it is cat or dog. Okay, that knowledge base it has gathered, we call them as model. All right, the customized algorithm we can call them as. Suppose we want to see a strange cat also has the features of dog. So if you want a model that can accurately identify whether it is a cat or whether it is a dog, so such model can be created using a SVM algorithm. We say. Okay, we are making a statement that we can use a SVM to do that. We just need to have the inputs being added with a past labeled data. Then we have to have the model training of these images, and then new data you can give it to the model which is ready to give a prediction. Okay, so this is new data. We don't know what it is, and when we give this thing to this model which is able to predict now, will give you whether it's a cat or it's a dog. It's a small architecture that is there. How it is there, we'll see that later. So SVM algorithm can be used for face detection, image classification, and text categorization, and many more video surveillance or many video processing things. All right. Okay. So the question here is how does it create a model using SVM? SVM says I will create a hyperplane that is my decision-making boundary, and that decision-making boundary is whether I will be having, for example, I have two categories in the previous this time. I have the green dots, I have the blue dots. Okay? And we are saying these two things are our support vectors. Support vector for what? What I'm supporting? Supporting the boundary creation, where I should draw this dotted line. I'm supporting to that. Okay. And why I'm calling them?
Anything exactly falls on the maximum margin, sir, then the model will be in confusion.
Maximum margin
Will be other confusions.
How many?
If anything falls exactly on the maximum margin line, sir.
Margin line. For example, this is the line. For example, this line. Okay.
So the model will be under confusion whether to mark it blue or green.
Obviously, once you have those points being near to each other, then you have to make a decision whether in this one or this one. And obviously, you understand based on our previous examples, we can find out based on the distances which point will belong to which cluster. So based on that, obviously, you can divide this.
Also, in that case, this existing this continuous and dotted lines, they will be arrows, and another new plane will be drawn.
Yes,
New
yes,
support vectors will be created.
yes, definitely. If new points will come, which are actually crossing those dotted lines, definitely those new points will become the new support vectors to draw the new lines. Okay, let's see some more examples on it. Yeah, we saw this one. We have this one also. Okay, we have sufficient numbers. Okay, we have class A, class B, and we are trying to draw different lines which best fit. We initially told in the explanation that SVM's main target is to find out that best fit line, all right, or boundaries, best fit boundaries. So here it is trying to draw all possible lines which can become our best fit line. But here is the best fit line which is separating these two clusters. These are not these colored lines. This orange and blue are not able to properly separate two categories. So that's why this black line will win the probability of becoming a hyperplane line. So in the second graph, you can see we have x-axis, y-axis, and these will become our support vectors, which will allow us to draw this width of blue patch. Okay, blue patch might become smaller if those support vectors would have came very near to each other. Okay, so here you can understand that this is the margin. So what is the meaning of margin? I want to understand. Margin is the gap. Whenever I want to take a printout in A4 sheet, on the left side there will be a margin, on top there is a margin. Why we have it? Because we wanted to have some gap of white on top. From there I want to print something. Okay. So why do we have those gaps? That's a boundary. That's why I don't want to cross the boundary. Before boundary, I want some space. On left side, I want to make a pin or something, I want to punch it. That's why I just don't want to cross my boundary of printing. If I remove the margin, what will happen? If the print will, your actor starts printing on the boundaries of the paper. I don't want to miss that. So what we'll do, we'll just leave some space and then we'll start some content. Alright? On either side of the paper, you leave the margin because you don't want to cross the boundary and you want to save the content. Same thing you try to imagine here. We have the boundaries here as a gap between the two clusters. That's what we're trying to draw the boundary, and the boundaries may expand or contrast. Okay. Okay. So here we have two classes, class A and class B, and these clusters are having the nearby values of this one, of this line. So whatever distance we have from this line to this line will be my hyperplane. It will be the negative or the positive, but I have a hyperplane margin being set. These are the margins that I have, and this is my best fit line, and this is my gap, and this is the end of the line, and that we are going to use it because of our clusters. All right. So that is my best fit line. Earlier we were trying to do what is the slope equation?
Y equal to X
Y equals to mx plus c. We are trying to use, and we are trying to use the trying to draw the line. Okay. Now we have a different mechanism of separating the clusters. I am trying to find out who are the nearby points which I can use it to draw my line exactly parallel to that. All right. So if we have multiple clusters again, then we will have different lines being coming. In the same plane, and then we have multinomial classification. This is just basic classification we are trying to do, which is having presently two outcomes: pass or fail, yes or no. All right, blue or yellow. Right out. So here you can see I have the class 1. This is class 2. I have this red line, and this is my gap that I have between the two groups. So any new point that you want to come, the new point, for example, star or the dot, the new point will come. The new point will be decided based on this boundary itself. This boundary itself. Okay, whichever points are on the either side of the boundaries, so they will belong to that group. Okay, so that will be decided by these only, because they are very near to that boundary of becoming merging to each other. Both clusters, if they come very close, they become one of the cluster. They become one of the cluster, right? If they merge together, they become one of the cluster. Only one cluster, not two clusters. One group they become. So they will not come near to each other. So we need to take care of that. And any new point that is going to come, that will define. That will be positioned based on the existing dots that you have or existing points you have. And if the point is becoming here, for example, it comes, okay, this line will move and the margins will be shrinking because the new point is arrived, which is having the different value. All right. So that's how your SVM will help you in deciding the classification based on the support vectors that are available in the boundary. They are sitting exactly at the boundaries. They will decide which point will go in which places. And any new point as a question you are giving to the model. Model is just one model. You are asking next question whether this will be true or false. So it will place that dot or the question that you are having. It will categorize them into those two clusters, and that is the answer that the model is giving it. If, for example, if I say the green dots are dog and the red is a cat, if I say, so I'm showing the photo and I'm telling in which group you will put this photo in. So the support vectors will give them the maximum possibility of whether it is a cat or dog. Okay. Those boundary values are nothing but the maximum characteristics that the object can have. All right, all the characteristics we have it, but these are the decision-making characteristics. All right, critical characteristics which I can say boundary characteristics. Based on that itself, I can say whether it is a dog or cat. All right, so that's why there are two strong points that we are considering as a boundary. Then we can make the decisions very easily. Yes. All right. So those are characteristics we are trying to put them. So they are support vectors we are taking help of, and then we are saying this new photo belongs to cat or it belongs to dog.
Support vector is new inputs.
Supporting the new inputs.
We are giving the
New value.
new value. This is a cat or dog. That is a support vector.
No, the existing values which are sitting at the boundary will be the support vector. The new value will come, and to decide where they should be classified will be done through these support vectors. Okay. You can see there are a lot of lines. There are randomly lines being drawn, and we're just trying, just randomly trying whether it will fit or not. Just trying to fit in the first graph, and we see that only one will fit, and I think this will fit on the boundary, and one of them we need it at the middle, and that is going to fit, and this will become this is optima hyperplane. and these are my boundaries. And boundaries have been drawn as a with a dotted, so that we can understand that they can be removed or they can be adjusted. That's why we are having dotted. And one permanent line we have, that is my optimal hyperplane. That is not going to change. Alright, that's been optimally added there only. Okay, this is my maximum margin where they can have the adjustment of the values. Okay, this is x2 and x1, so that's how it is been available. And these dark shaded thing are your support vectors. Okay, let us see something about it.
So when the new value is far off greater than
If it falls in the middle, you have to move to the middle line, obviously. Because that's what we initially tried, best fit between the two groups. We try to adjust ourselves to the line. Then obviously it has to change.
both the sides of over the middle line.
Then obviously it has to have a very narrow margin, and you cannot bifurcate. Whether both look like a cat only. Both look like a cat and dog. You're taking that possibility. One photo is looking 99% looking like a cat, as well as 99% looking like a dog. That possibility. That is very rare. Obviously. It has to have some characteristic which can separate it. So it is going to bifurcate. I mean, possibly they are seen as I said. Okay, let's see something about it. Classifying data. Okay, we have one more example. Let's see one more example. For example, in a class of fruits, to perform multi-class classification, we can create the binary classifier. What is binary classifier? Yes and no. Okay. For each fruit, for say mango class is one of the class. There will be a binary classifier to predict if is a mango or it is not a mango. Is a mango or not a mango? Options. The classifier algorithm with the highest score is chosen as an output of SVM. Okay. The classifier with the highest score, will be chosen as an output of SVM. That is your SVM for complex number, non-linear separable. SVM works very well with without modification of linear separable data. Okay, let us see this. We have a graph which is having the green dots, and you have this linear line being separated. Linear line are used to separate the two clusters. Okay, and second we have this is non-linear separable data. Non-linear separable data. So here we are saying SVM works very well without any modification for linearly separable data. Linear separable data, that is straight line. Linearly separable data is any data that can be plotted in a graph and can be separated into a classes using a very much straight line. So when you have this values, you will be able to have that, and this is going to be the non-linear separable data. As you're saying, the all data is mixed into one place and is not able to see as a two groups. Then there will be a non-linear separable data. You can have it, and these kind of circles are not only exact circle. You could have the unstructured circle also, a distorted circle also. You can put them, and you can make them one of the multiple groups. All right. Okay. So most cases will be of this one only, that is having a separable data. All right, binary separable data or linearly separable data you have. Radial functions, that is for the other data. We wanted to have. Okay, here is an example. So SVM, if you want to have it, you can have the data set ready, and whenever you install this one, most of the algorithms that are available into SKLR will be your machine learning algorithms. Once you install this library, you will be free to use most of the algorithms that are available as supervised, unsupervised, as well as your machine learning algorithms, all machine learning algorithms. You'll have model selection, you'll have train test, you are making the classification, you are having a training testing data separation, and you are having SVM dot SVC, that's support vector cluster, and you have kernel, which you are selecting as linear or secular or non-linear. You are selecting linear, and model dot fit. You already created an algorithms model here with the hyperparameters here. Okay, these are my parameters which modifies my existing algorithm. So what is my algorithm name? It is my SVM algorithm. So I have the model ready, and that model is nothing but my algorithm, present algorithm, without any customization. So now we can have model.fit. X train is my data, Y train is my answers for the X train. X is my question, Y is my answers, or you can say together as labeled data set. So once I have that, once I train this is a training mode presently. Model.fit, whenever you see any of the algorithms, machine learning algorithms, you consider that the training is happening. It is started. Alright. Once the training happens, any training that has happened will be stored in the model. Alright. So now model is customized. So model.predict, when you do, that means model is ready with the training. Now it is ready to predict. So once we wanted to predict, what do you do? What do you ask first question? So where are the questions? The questions are regular test. How about this one? This is train. So how you divided them? Training data, testing data, how you divided them? You divided them here. Who helped you in dividing the data? Train, test, split function has divided the data into these many parts. Alright? Because you have told how many parts you want, that's why you have been told. So test data, how much you want? 50% of whole data I want for testing. You are deciding, and you are telling you are giving x value as well as t value, and you are willing to give that thing from here, and that you are giving it from this function, that is your make classification, that is 100, 5, n classes, and all these things you are taking it from the header files that you are taking. Okay. Make classification is your data set. From there you are taking the data, and from there you are making this x, t, and that is supplying here and splitting into multiple parts. One is for test training, one is for testing. Questions only. Two divisions of questions. 50% data for training, 50% data for testing, and 50% data for test training of this x, and this is for testing of this. I mean, this is to verify actually. This is the answers of the question that you are asking for your model. Alright, later you can verify whether the answer of given by the model and the answer that we are ready with already are matching up. Okay, that you can do with the x. Okay, here you can do with the accuracy score. Okay, model.predict x test, when you do, it will give you the answer here in the y, and it is not at all stored here. You understand? This is just used as a one of the what you can say stepping stone to execute that thing. You consider that like a obj1 dot some function. All right. So inside obj there is an algorithm which is helping the predict function to predict something and give the answer in a y. All right. This is your dependent variable. These are your independent expression. All right. So this will execute. That is model.predict will execute and will give you the answers. And at the end, you are also taking a x train and you're trying to find out what is the outcome. Okay. You already use this x train here while training. And this is the testing data that is not at all seen or not at all learned by your model. And those questions which it has not learned, it is trying to answer those questions. The one which is already has got trained for. Alright? So one thing is untrained answer, one is trained answer. That is quite good. And we have sklearn.metrics. Metrics is for measurement of performance of the algorithm, and we have accuracy score. Accuracy score y, comma y test. Y is my answer that I have received from the testing, and y test is my answers for these questions. Tested questions. This is my answer. Alright? This is my answer. So I am going to give both this answer and this answer. And I am asking accuracy score function to check whether both the answers are right or wrong. If any wrong answers are also there, we just calculate the score, how much accuracy is available, how much it is matching. For example, 1 to 10 numbers are right, and another time, another set, 1 to 9, 1 to 10 are right, but I'll do the mistake in one of the number. Then we'll say one of the number we have done. So 10% problem is there, so 90% accuracy I can say. Okay, if 10 numbers I consider 100%. One number I missed it in the second list. So what do you say? 90% matching, 10% you missed one number. Get it? That's what we have given. Instead of numbers, we have given y comma y test. Alright? Okay. So you just need to understand what they are doing, how they are doing, and how do we execute them. You can see that later. Right? Understand the functions, what they are trying to do. Accuracy score, they are trying to check whether it has given the right answer or not. Then we print the score, and there is score 2, that is for this one. Accuracy score of y2, which is trying to answer the questions which it has already understood. It has already got trained. And then we have the y train as answers of y or x train. Alright. So two phases we have. One is training and one is testing whenever we create a machine learning programs. And this happens in supervised machine learning algorithms. During supervised machine learning training, we will supply two things. One is the data and its expected outcomes. Two things will supply. While we are training, while we are testing, like this statement, as we are testing here, whether it is going to give me the right answer or not, that phase we are going to call it as testing phase. One was training, where we have given question and answer together. That means your dependent variable and independent variable together. The algorithm has got to know what the question is and what the answer is. Next, we are trying to test it here, and once we test it, we will be understanding whether the answers for these questions are right or wrong with the help of accuracy score function. Alright? So if the score is very low, that means model is not predicting properly. Because my answers are ready, it is the answer given by the model is not right. Okay? Then the score will be very low. If the score is very much high, like 99, then the model is working very much perfect. Okay, so this score 2 is trying to test with a y2, which is predicted by the y training data's answers and training data's questions, outcomes, prediction. Alright, y2 is the prediction of data which it has already trained for. Y is the answer for the data or testing questions which it has not trained for. Okay. Score 2 also will print it, and matplotlib is for just to display visually. Color we are deciding, and scatter we are using x of train and a colon of 0, x of crane colon of 1 and c equal to the color. Color is this whole thing. And then we are going to create the model dot coefficient underscore of 0. That is your first numbers. And then minus w of 0 divided by w of 1. That is this one. You're trying to use the array or list of values that you are receiving from the coefficients of the model. And then you are using the numpy dot line space and yy. You're trying to create the SVM here. Okay, with this one, you're trying to create a hyperplane. And to create a hyperplane, you're trying to find out the line space. That's your margin. Minus 2.5 and plus 2.5 from the initial point. And then you are creating a yy. This is your xx plane. And this is your y plane, and this is your w and t. And you are going to plot them. And axis is off. PLE dot show. It is not being shown. You have to execute it to show them. So we need to have all the packages, whatever they are saying, we must already have it. Let us see if all the packages we are having ready. We don't have sklearn. Okay, it is saying import sklearn dataset could not be resolved presently. So how do I install it? So I have 4 errors. Fifth, presently I am in 3.7.2. In that I have it. Okay, I'm presently in the base. Presently, I'm in the base. Okay, let us install. Pip install sklearn. Failed to establish a new connection. Check if any of you can install sklearn. Install. Let me install. SQL installed? Yes. The spelling is SQL only, right? Check output. It's having the line with the points. Start again. Yes, sir.
If I use the value, it is different also. So SQL not linear modeling, you import logistic regression.
Okay. The article is confusing.
So can I check just the SQL model?
Yes, yes.
How I can check this? So that should show me whether it is restored or not.
On a space list. On a space list. You can use.
Honda space test SQL answer.
If you play it repeatedly, so those lines will change as well as the dots will change because the data set that you have taken is dynamically generating the random values. So that's why that line, the best fit line between the two groups is going to be changing. Alright, so that's the thing that you can observe. And here in this one you can see you don't see those dotted lines there. Okay, you only see one line available. That one line is your optimal best fit line, and the space that will be having on either side of it will be the margins. Okay, that will not be seen, and here we just have shown that in the dotted line in the hyperplane. Right, whatever the plane is, whatever the gap is there, that is the hyperplane. And here in the most of the cases, the line is actually touching all the points. Okay, is that right? So that's why you just don't have to see. You don't see much hyperplane margins here. You just have to see only one line which is touching all the other points. Okay, because that's the best fit line, or that's the best fit line that can happen, and that can separate the two groups apart. That's what the aim of SVM is, to separate the entities that are coming as a new values, as prediction values, and to separate them, we have to find out what is the best fit line and how does it align with the help of with the help of two groups here. All right. At what angle and at what place it has to move, it will do its own trial and error and align that line according to the best fit. All right. As I showed you in the earlier also, there will be a lot of lines available. So those lot of lines are actually trial and error that it is internally doing. But what you're getting on the screen is the final outcome of its trial and error. All right. So if you look at its processor in any of the videos, you will see that it is trying to fit in all the other places, and you find one best place where it can finally sit and say that I am separating two groups. All right. That's what it is. Abhishek, is it executing? Got it? Okay. Others, those who are not getting solved.
No, sir, it's telling no command as owner space test.
No, have you executed this thing?
I tried cycling. Then also it's not giving me a solution.
Show me error.
No command as owner test.
Okay.
I tried both owner space test scaler.
And you are trying to install?
No, sir. I'm checking whether it is installed or not.
No, it is installed already. It is installed. So you can take the new cell and you can try this thing.
I want to check its version, sir.
Version you can it will execute no of looking at version. But we can look at the version in the Anaconda. In Anaconda, if you click on environment, that will see the name, version, whether you can update that or not, the new version, then you can check it. Let's execute
But programs are executed, so without any action.
Then no problem. Okay, that is one program that you wanted to execute, and we have some more programs that we have to execute. All right. So you have seen the optimal line, and you see there are a lot of dots are there. Okay, the black dots are the light gray dots that you have. We see the mixed dots available as a random data, and it is getting separated with the two clusters, right? And it is not telling you what clusters are there and what is the label of that clusters. It is randomly choosing all those points. If you want to actually trying to find out all these kind of separate points or specific points, you have to take the separate data points in Excel sheet, read the Excel sheet, and use those Excel sheet data as a data points, as a X train and Y train, and then you have to give them. Then you will be able to plot this kind of. All right. You try to find out the program, and you get me the execution of that SVM. Okay. This is the example that we have told you. Is available and what is its efficiency? But since it is famous because of its efficiency, you just don't have to consider only the execution part of it. You just have to consider the application part of it, because during interviews or anywhere where you are discussing, you have to understand different algorithms, their working and their efficiency. Because once you learn all of them, or for example 4 algorithms you learn, which does the same work, now you have to choose one of them. How do you choose one of them? You have to choose based on your use case, how it is useful to you. So how do you understand that? It is best way to do that is to understand and tell the applications of it. Okay, how it is useful to me. With that, I will be able to make a decision very well. That's why I have a habit of looking at the algorithm as a tool, and where can I use this tool? Two things you just have very clear in your mind. Then any question that will be asked to you, you can obviously answer it because you already understand why that algorithm exists firsthand. All right, it's very clear to me. Just do not consider the algorithm is anything bigger than what you can think of. They are very small algorithms that you can just understand. The algorithms, this is their work. This is how I can use it whenever I have a situation to use it. That's it, finished. All right. So now onwards, have a small notebook. Try to write the algorithm name and one statement after that. After that, one statement, whatever you understand about the algorithm. That will give you an overview of index of all the algorithm and its working and application of it. This practice, if you have it, you will crack any kind of interviews where people are asking about algorithms, and that's important part of any interview that they will take. That's a core part of technical interview where they'll ask algorithm and they ask more detail about algorithm if you are very interested. If you just tell them the application of it and this is the tool with which we can do this thing, then that much is enough. All right, and obviously that is the questions will be given on the role that you are taking. If you consider yourself a fresher and you understand and you learn these things, then it's very lightweight. Interviews that will happen. Okay, they just ask. They will definitely train you for 3 months once you enter. They just wanted to know how fast you can learn and how fast you can answer the question what they are asking. Okay, there is an attitude of a learning. That's what. Alright, so whatever we are learning here, just try to understand where it is being used, what are the capabilities of those algorithms, and how can we will do that in the next class. Don't miss the classes further now. Alright, then we'll stop here today. And the assignment for the next class will be I want all of you to bring up one machine learning game that you can execute it in the class. Okay, and I want you to download it and try to execute it. If errors are there, just solve those errors and solve those errors from Stack Overflow. If not, send it to me also, okay, in the group so that everybody can. Okay, one machine learning game. Fine, this is the assignment. We want all of you to bring up the GitHub repositories with all those code. Okay, and try to